Let us take a look at an example to understand the concept of multi-period compounding. If the nominal rate of interest is 12% per annum, calculate the effective rate of interest when a sum is compounded annually, semi-annually, quarterly, and monthly. So as we know, the nominal rate of interest is generally expressed as yearly interest. However, the effective rate of interest depends on how many times the interest is being compounded. So the effective rate of interest would be different when the interest is being compounded annually, semi-annually, quarterly, monthly, daily, hourly, and so on. So now, as we had discussed, the formula to convert the nominal rate of interest into effective rate of interest is basically the same as the compound interest, but with the principal amount of 1. So 1 plus I to the power n, and then we'll do a minus 1 to convert into percentage, where n is the number of compounding periods and I is the interest per compounding period. So let's take the case of annual compounding. So in case of annual compounding, since the tenure is considered as 1 year only, so the total number of compounding periods n is equal to 1, and the interest rate per compounding period will be the same as the annual interest rate, which is 12%. So effective interest rate is equal to 1 plus, now I is expressed as 12 divided by 100, so 0.12 to the power n, which is 1 minus 1. So 1.12 minus 1, so this is 0.12. So basically 12%. So the effective interest rate is the same as the nominal interest rate. Now let's move to semi-annual. So in case of semi-annual, the number of compounding periods becomes 2, and the interest rate per period will become 12 divided by 2, which is 6%. So the effective interest rate will be equal to 1 plus I is 0.06 to the power n, which is 2 minus 1. So 1.06 square minus 1. So 1.06 square minus 1. So this is equal to 0.1236, which is basically 12.36%. Now let's move to the third one, which is C, which is quarterly. So in case of quarterly, the number of compounding periods become 4, and the rate of interest becomes 12 divided by 4, which is 3%. So the effective interest rate is equal to 1 plus I, which is 0.03 to the power n, which is 4 minus 1. So this becomes 1.03 to the power 4 minus 1. So 1.03 x to the power y 4 minus 1. So this is equal to 0.1255, which is equal to 12.55%. Next we'll do monthly. So n in case of monthly is 12, and I is 12 divided by 12, which is 1%. So effective interest rate is equal to 1 plus 0.01 to the power n, which is 12 minus 1. So this is 1.01 to the power 12 minus 1. So 1.01 x to the power y 12 minus 1. So this is equal to 12.68%. I mean, this is equal to 0.1268, which is equal to 12.68%. So as you can notice, the more granular we become in terms of compounding, that is, the more compounding periods, the more is the effective interest rate. And the reason is because more the number of compounding periods, more will be the interest earned on the interest for the previous periods.